planet we know of that sustains life.
There are approximately 7 billion people on this planet.
The population continues to rise.
How much longer can our planet hold all of us?
What is the maximum capacity? How much longer will our resources sustain us?
Will global warming actually one day be the reason that we need to leave our planet?
We're gonna need to look for another place to settle.
Astronomers are out on the look for planets that can support humanity. Mars has always been the top candidate where life can be found.
But are there any other candidates in our solar system?
What theories or evidence is currently out there that may lead to any discoveries?
Is building a space habitat for humans to live on even possible? What are some of the potential planets that may contain life?
Well,
let's find out.
In order for us to choose the most fit candidate for space survival, we will have to discuss the basic criteria needed for a planet to actually be habitable.
Number 1, planets that are around the same size as Earth. Well, I guess we would prefer a planet that is slightly bigger. It really depends on why we're leaving Earth in the first place. If it's because things are getting a little too crowded, then a bigger planet would be preferable. Also, planets that have around the same size as ours does usually have the same amount of gravity.
Actually, that isn't true. The amount of gravity does not depend on the planet's size. There are planets bigger than ours that have lower gravitational forces, and planets smaller than ours that have higher gravitational forces. It really depends on the planet's density. The more dense the planet is, the higher the gravitational pull and vice versa. Also, usually the more dense a planet is, the greater the mass.
Well, okay, fine.
I'll carry on to the second criteria.
Sure, go ahead.
Number 2, the planet has to be located in the solar system's habitable zone. A habitable planet has to be just right distance away from its star, far enough from its star that it's not too hot and close enough that it's not too cold. Scientists call this imaginary ring region around the star habitable zone or the Goldilocks zone.
Haha, Goldilocks, but why is it called that?
It's named after the fairy tale because they orbit where the conditions are just right for life. Scientists also need to identify where the habitable zone starts and stops, as they only often do this with stars that have multiple planets orbiting around them, because if a star didn't have any planets orbiting it, then what would be the point? Our planet, along with Mars, are within our solar system's habitable zone.
Any planet that is found within its habitable zone should be able to hold liquid water on its surface without it evaporating from heat or freezing from cold. So planets further than the habitable zone would be too cold and frosty for life, while planets between the star and the habitable zone would be too hot and steamy for life.
Planets found within the habitable zone wouldn't necessarily mean life is guaranteed to be hosted on it, but it increases its potential of hosting any type of life.
Yeah, it's like one more important check mark on a long list of requirements.
Yeah.
So the third requirement would be the planet's parent star has to be stable. The planet should be able to rotate on its axis and revolve around its parent star peacefully without being attacked by solar flares emitted from the surface of its parent star.
Yeah, that's pretty much it. Is there anything we're missing?
Nope.
Yeah, so that's it for planet requirements.
Wait, one more.
What is it?
Well, scientists need to calculate the thickness of the atmosphere for the celestial body.
Interesting. Wait, how do you even do that?
So scientists can do this by observing the molecules in its planet's atmosphere. A planet will absorb a certain amount of energy from starlight and radiate the rest back out.
I'm guessing the amount it radiates back compared to how much it is absorbed allows scientists to measure the thickness of the atmosphere.
Exactly, and an example would be Venus. It's receiving more starlight than Earth is because it's closer to the sun than Earth is. And it also seems to be way brighter in comparison to Earth. They calculate the thickness levels of Venus's atmosphere by measuring the input starlight from the sun going into the planet and the output brightness and energy levels being emitted by Venus. How much of this energy is trapped determines the difference between a beautiful turquoise sea and erupting volcanoes on the surface of a planet.
Yeah, wow. So that's why Venus is in the habitable zone of our star, but it's still too hot to be colonized by any living creature.
Oh, and one more thing. The planet has to be a travelable distance away from our planet. We will get into further detail on how to get there later on in the video.
That was a pretty long list. Let's tell the class the few celestial bodies we actually found that we can possibly inhabit.
Yeah, before we get to that, let's explore the possibility of the human race making a spacecraft or multiple spacecrafts that have livable conditions that can sustain hundreds of thousands of people for multiple generations.
Wait, is that even possible?
Okay, well, this idea relates very much to the Netflix series, The 100. So basically, It explores ways that humans can survive out of Earth's atmosphere and some challenges humans may face when living there. In the show, after a nuclear apocalypse took place on Earth that wiped out all life, humans are forced to resort to space habitats. The apocalypse was predicted, so 12 gigantic space stations were made prior to the nuclear outbreak that were able to hold more than 4,000 people. Of course, the TV show didn't show how these people were selected to be the lone survivors.
They probably picked people with diverse professions to meet different human needs because they weren't just staying there for 1 or 2 years.
So resources that pertain to life were scarce. Breathable air was the real problem. So the only way to make the air last longer is to get rid of people.
Mom? What is this? They're killing us, are they? Reducing population to make more time for the rest of you.
No, listen to me. You're being sent to the ground. All 100 of you.
What?
So all crimes, even the slightest ones, were punishable by ejection into space.
Although they were not allowed to do that to criminals under 18, they also weren't allowed to breed whenever they wanted. They would have to be given permission to do so by the leading council, so having a baby was pretty much illegal.
This crime was punishable by ejection of the mother, the father, and the child.
After 97 years of the human race living in the celestial habitat, under horrible society standards, the population had dropped down from 4,000 to 2,400 people due to the need to preserve resources. Now there were the criminals that were below 18 but couldn't be ejected into space. There were 100 of them, hence the name of the show, The 100.
Java, the leader of all space stations, needed to find a way to punish them but not kill them.
Our crimes were petty, but overcrowding made us expendable. We all tested authority one way or another, so now we get to test the Earth to see if mankind can finally go home. What was that?
That was the atmosphere.
Earth.
Retro rockets are next in 3 seconds! 2, 1!
The air could be toxic.
If the air's toxic, we're all dead anyway.
Scientists predicted that the Earth should have cleansed itself by then, so they wanted to make their first expedition back to Earth to check if it was habitable. So they decided to send their young juveniles there.
The leader of the space station decided to do this because it was a punishment that wasn't going to kill them. So the parents of the U-18 criminals couldn't argue, or if they tried to, they wouldn't succeed.
Yeah, well, they didn't know for sure that they would live. It was more like a trial thing. There was no certainty of life on Earth, so they all could have died.
But of course, this is a TV series, everyone didn't just die. They made it dramatic and made it look like they were gonna die, but they didn't. So basically, to wrap things up, they get back to the Earth, they found survivors of the nuclear outbreak that happened 100 years ago.
97.
Same thing. The survivors were called grounders. Conflict starts between those groups and they eventually become allies because they find out that they aren't the only survivors living on Earth. They figured out they were stronger together than apart, so they teamed up against the other groups, and yeah, that's it.
The plot of The 100 is a nice thought to have, but it's not that realistic. Aspects from The 100 that are flawed and aren't realistic, or aspects that aren't really clear in the movie. 1. How would the survivors on Earth adapt so quickly to the nuclear radiation, given that time span of just 97 years? The producers of the show did not point out how they survived. They were just kinda there when the 100 came back, so it's kinda confusing.
Number 2. How did they create gravity on the space station? They were all walking around like everything was fine and dandy. They were just like, it's not like my body's deteriorating from the lack of gravity to work my muscles and bones. I'm totally fine right now. And right after the juveniles landed on Earth, they were able to walk. They shouldn't have been able to walk due to the lack of gravity in space and how much stress Earth's gravity is putting on their muscles that haven't been used for 97 years. But apparently they had gravity on the space station, so I guess it's fine to have them walking right when they get to Earth.
Number 3. How did they stop the public from finding out there was construction going on for 12 colossal space stations that are going to be orbiting Earth? Like, if other countries knew there was going to be space stations that could save their lives from the radiation, I'm pretty sure they would want some salvations for themselves too.
No wonder there was so much beef between the 100 and the grounders.
The truth is, they should have found out, cause where are they getting supplies from? Who's paying for these supplies? Somehow word should have gotten to other countries, so they would have wanted to get involved.
So hypothetically, if humans had to actually build a spacecraft, let's highlight key aspects and requirements for living aboard a spacecraft for multiple years. Number 1, the proper amount of gravity. The most realistic method of producing artificial gravity aboard a space station is using a centripetal force to produce a pulling sensation towards the floor that would mimic the effects of gravity.
Centripetal force is the force that is created with an object as it spins. Using this method to simulate gravity on a space station would mean spacecraft engineers would have to calculate the size, mass, and density of the spacecraft, measure the velocity as it spins, then adjust the spinning speed of the spacecraft so that the outward pulling force will match the force of the Earth's gravity.
Let's say the spacecraft possessed the shape of a short cylinder, and it spun around its middle axis. The curved wall of the cylinder would be the walkable area of the spacecraft, and the circular face of the cylinder would be the walls of the spacecraft.
Okay, so other requirements like protection from radiation, of course,
Sufficient air pressure and oxygen supply,
proper temperature control,
space to store all resources pertaining to life, food, water, etc.,
space to store building materials, fuel, and preparation for any sort of mishap or malfunction of the spacecraft.
space to store materials that we will use to carry on research in different fields of science and to carry on further space exploration. Because let's say the human race was suddenly living on a spacecraft, it would be weird for all fields of study to just be stunned, and for humans to have no progression of knowledge. So in order to continue, we need certain supplies for that.
Proper selection of humans to go on spacecraft, like a diversity of jobs and professions for different human needs or mishaps that may occur.
Supplies and criteria for different professions, and that's about it.
Okay, so now we can get to the other habitable celestial bodies that aren't man-made.
Yeah.
What do you want to start with?
Well, the two moons we discussed a while ago.
Oh yes, Europa.
Europa is a potential candidate that might contain life. It's a moon, but what planet does it belong to?
Jupiter is one of the 67 moons that actually belong to this Jovian planet.
Oh, okay, anyways, we know that essential prerequisites for life are energy and water, and now scientists believe Europa possesses them.
The tidal heat could even keep Europa warm enough to have water. Looking good so far.
From the picture taken by the spacecraft Galileo, the surface actually looks like broken glass.
Now that I think about it, it kinda does. Oh, but maybe broken glass, that's like repairing itself, if that makes sense. But these segments of broken glass have broken the crust into plates as large as 30 kilometers.
Also, there is some evidence that Europa could be slushy beneath the ice crust and might get warmer at greater depths.
Warmer at greater depths. Wait, I don't remember finding that.
It's not exactly confirmed yet, but evidence gives it a possibility. But it would be warmer due to internal tidal heating from interactions with Jupiter.
Looking at many pictures of Europa, something came in mind. Craters. They are small dents caused by space debris or even an asteroid.
They are said to be the most common surface features on many solid planets and moons.
Geologists determine the approximate age of a surface by counting the number of craters.
The average temperature in the equator is roughly about negative 160 degrees Celsius.
Sounds like it's a little chilly outside.
Stop.
Fine.
I guess Europa simply represents too many difficulties to be reasonable to settle in. Is it big enough?
No, not at all. It's smaller than our moon, but it's still bigger than Pluto.
Okay, so no check. Is it located in the habitable zone?
Nope. But like theories say that Jupiter's gravity causes friction which warms up the planet, but not enough to sustain human life.
Is the parent star stable?
Well, it's our sun, so yeah.
Is the atmosphere similar to Earth's?
Has oxygen, but its atmosphere is too thin so the air pressure would be insufficient for human life.
Is it a travelable distance?
Well, yeah, maybe in a few years, since a man-made spacecraft, Voyager 1, has gone past our gas giants, and it's possible for us to one day get there.
True, so Europa gets a 1.5 out of 5 on the habitable test, because its star is stable, and we gave it a half mark for travelable, but it still fails. There's too many difficulties with this one.
Let's move on. I think we have one more moon.
Damn it, I keep forgetting the name. What was it?
Titan.
The largest moon of Saturn.
It's still questioned and a top of scientific research.
Right now, we know that it's far colder than Earth, along with the lack of liquid water on the surface.
These two factors contributed to reasoning for some scientists that believe life there is unlikely.
However, it has a thick atmosphere which is rich in carbon compounds.
The surface of Titan contains bodies of liquid methane, which some scientists say these liquids might be related to living cells in water.
Currently, its surface temperature is about negative 179 degrees Celsius. The ice remains solid. There's a chance where meteor strikes could create impact oases.
These are craters where liquid water might persist for longer, right?
Exactly.
Nonetheless, Titan could become warmer in the future. The sun will eventually become a red giant, so the surface of Titan can rise up to negative 70 degrees Celsius.
Oh right, and scientists do say that this temperature is high enough for oceans of some sort of water mixture to be on top of the surface.
Laboratory results suggest that Titan contains enough organic material to start a chemical evolution to what is thought to have started life on Earth. Okay, so Titan, is it big enough?
Nope, it's a moon.
Is it in our system's habitable zone?
No, atmosphere is way too cold and doesn't contain water. It has liquid natural gas, which may come in handy if there is a need for natural gas later on in the future.
Is it star stable?
Yup, it's our sun.
Is the atmosphere similar to Earth's?
Nope, it's filled with thick evaporated natural gas, which is extremely toxic for humans.
Is it a travelable distance?
Kinda, for the same reason Europa is.
Okay, so that means Titan also gets 1.5 out of 5. It fails the habitable test.
Wolf 1061c. In this system, there are exoplanets that belong to their dwarf star. Some astronomers believe this is the best exoplanet out of its system because it is located in the habitable zone. It's located in the inner part of its habitable zone. This is also the closest habitable planet to the Earth, and it's approximately 14 light years away. It is 0.08 AU away from its star in comparison to Mercury, as Mercury is 0.3 AU away from our sun. You may be confused, but it is able to stay this close because the star it is orbiting is a dwarf, and it's also red, so it's cooler than the average star. Also, because it is so close to the star, it is likely to be tidally locked, which means that one side is permanently facing the star and the other side is permanently facing away. On the same track, this could result in extreme temperature differences on the planet. The terminator line that separates the illuminated side and the dark side could be habitable. Wolf 1061c is 1.5 times larger than Earth, so that means more space. Wolf 1061c. Is it big enough?
Yeah, it's 4.3 times the size of Earth, so it has more than enough space.
Is it in the system's habitable zone?
Yes, it's closer to the inner edge.
Is it star stable?
Yup, usually red dwarfs aren't, but this one is, so that's good.
Is the atmosphere similar to Earth's?
There's probably a lot of gravity. Wolf 1061 is said to be rocky like Earth, which means it probably has the same amount of density. So since it's 4.3 times bigger, it probably has too much gravity, which means the atmosphere isn't similar.
Is it a travelable distance?
It's 14 light years away, but it's the closest habitable planet to us. We will just say no, because it would take some time for humans to learn how to travel at the speed of light. But there is still a chance where traveling at the speed of light doesn't exist. And even if we could travel at the speed of light, it would take 40 years to get there, so it's kinda dumb.
Wolf 1061c gets 3 out of 5, so it's definitely a top contender.
Gliese 581g.
This is another planet that is named after its parent star.
Astronomers calculated that it is approximately 20 light years away from Earth. An interesting fact that is the 89th closest star to the Sun.
Speaking of the Sun, Gliese 581, the star of the system, has a mass that is approximately 1/3 of our Sun.
Similar to Wolf 1061c, it is in the habitable zone of its system.
Astronomers first discovered and announced in 2010 as a planet that is close to Earth's mass. Its discovery was made using radial velocity measurement using the high-resolution Each-Shell spectrometer instrument.
The type of star is cooler than our Sun, so planets need to be slightly closer to each other for enough warmth to flow on its surface.
Again, similar to Wolf 1061c, the Gliese 581g always has one side facing its parent star and the other always in the darkness, which means it's tidally locked.
This means the region of potential habitability would likely be on the line between light and darkness.
However, there are still some downsides for this exoplanet alone.
Using data points from HARP's data, scientists only saw signals of 4 other planets in that system, but no sign of Gliese G. The signal amplitude for this planet is very low and only to the extent of a noise.
There's been many times where two groups with different beliefs argue over this exoplanet. Other groups asserted that as long as the planet has circular orbits, it exists.
A press release years ago by Penn State demonstrated that sunspots could affect planetary signals. Researchers concluded that 581T doesn't exist, then so does 581G.
But to counter this statement, a team in the University of London published that the statistical method is not adequate for identifying smaller planets. They urged for the data to be shown again by using a more accurate model.
So I guess it's still up for debate. Gliese 581g. Is it big enough?
Yeah, definitely. The radius is anywhere between 1.3 and 2 times bigger than Earth.
Is it located in its system's habitable zone?
Yes.
Is the star stable?
There's no information about any solar flares attacking Gliese, so I'm going to assume it's fine.
Does the atmosphere have livable conditions?
It's said to possess favorable atmospheric conditions.
Is the planet a travelable distance?
No, it's 20 light years away from Earth, so there's little chance of us getting there.
That means Gliese 581g gets a score of 4 out of 5 on the habitable test.
Despite being the most obvious candidate, we believe that discussing observations could lead to further discoveries or questions.
Which one is it?
After Earth, Mars is the most hospitable planet in our solar system. Some theories even suggest that it once held bacteria-like life.
Alright, certain geographic features provided evidence that billions of years ago, water flowed on the surface of Mars.
However, the temperature is currently too low and the atmosphere is too thin for liquid water to exist at the surface. Because knowledge of Mars is common, we won't get into the details, and we will just skip to Mars's habitable test. Mars. Is it big enough?
Yeah, it's slightly smaller than Earth, but it'll do.
Is it located in its system's habitable zone?
Yeah, it's right next to Earth.
Is Mars's parent star stable?
Yup, it's ours.
Does the atmosphere have livable conditions? The temperature is currently too low and the atmosphere is too thin for liquid water to exist at the surface. Is it a travelable distance?
Yeah, for sure.
Okay, so Mars gets a 4 out of 5 on the habitable test. So after discussing all these planets, moons, and systems, we haven't quite talked about how astronauts even get to these areas.
And what math is even involved?
There are certain ideas you have to consider and know before traveling these celestial bodies.
1. Speed of light is 299,792 kilometers per second.
There is 31,536,000 seconds in a year.
Kilometers per second multiplied by seconds in a year gives you 1 light year. Gliese 581 system is about 20.2 light years away.
If you travel at Voyager 1 speed, it will take you over 350,000 years to get there.
Voyager 1 was launched in 1977. Now over 30 years old, it's traveled more than 13 billion miles. Its mission so far has taken it to Jupiter and Saturn. By using their gravity to boost its speed, the little spacecraft has entered the record books. It might not look fast, but Voyager is racing through space at 11 miles a second. On Earth, 11 miles a second looks like this. It's 39,000 miles an hour. At this speed, we could circle the globe 1.5 times in an hour.
Present-day engineers have been thinking about the possibilities of building a spacecraft for celestial exploration.
It would have to be powered by atomic energy, or possibly antimatter, or possibly the natural gas on the surface of Titan. But in order to obtain that natural gas, we would have to send a manned spacecraft to Titan, or send a spacecraft with extremely intelligent AI that will be able to extract the fluid.
Main challenges of making a device like this wouldn't be technical, it would be more financial.
The society that makes it wouldn't really get anything back, because once they send their device on its journey, that'll be the last time they see it.
Constructing such a machine would require the greatest act of generosity, or the makers of the spacecraft would have to be the ones to be in the spacecraft as it makes its journey.
Another challenge would be the time it would take to get there. Even if you could fly 1,000 times faster than Voyager 1, it would take 73 years to get to Gliese 581.
In order to make interstellar traveling as efficient as possible, we would have to be able to travel at the speed of light, or at least close to the speed of light. This, however, is highly unlikely, because Einstein's theory of relativity gives us evidence that it is impossible to travel at the speed of light. According to Einstein's general theory of relativity, as an object moves faster, its mass increases, while its length contracts. At the speed of light, such an object has an infinite mass, while its length is zero, an impossibility. Thus, no object can reach the speed of light.
Also, according to Einstein's general theory of relativity, as an object moves obtain greater speeds in movement, time on the object slows down. Reaching the speed of light would mean you're traveling at zero time, so the theory has to prove its consistency. Therefore, traveling faster than the speed of light would mean you're traveling in negative time, which would mean you're traveling back in time.
In 1971, an experiment was conducted with 4 super accurate atomic clocks, which were set to the exact same time as a reference clock. The clocks were placed aboard commercial flights, and the planes flew twice around the world, first eastward, then westward. When the clocks returned and were compared to the reference clock, the clocks were no longer synchronized. The differences were consistent with the predictions of special and general relativity. This proves the theory to be right. Here are some potential methods we may consider in the future as technology advances or methods we have used in the past.
1. Conventional rockets.
These unique type of rockets create accelerations or thrust by burning a chemical propellant stored inside. This chemical is either a solid or liquid fuel, but a liquid fuel is recommended. The energy released lifts the spacecraft out of Earth's gravitational field.
This is a method used since the beginning of space age. Similar mechanics have been applied to Voyager 1.
However, Voyager 1 is set to run out of fuel in 2040, so this is an indication how limited conventional rockets can carry a spacecraft, but this could change as time goes on. It would take a high amount of energy that surpasses the current output of the entire world to send a spacecraft anywhere further.
2. Ion engines.
They work similar to conventional rockets, but instead of using products of chemical combustion for acceleration, they use electrically charged atoms.
The engine produces less thrust and speed than a conventional rocket, so they can be used to exit the Earth's atmosphere. But if it's carried into space by conventional rockets, then they could run for longer periods since they use denser fuel more efficiently.
This allows the craft to build up speed and eventually surpass the velocity of a spacecraft propelled by a conventional rocket.
3. Nuclear rockets. These are nuclear reaction power rockets to cover distances of interstellar space.
Nuclear rockets would be powered by a series of small nuclear explosions, possibly by using pure deuterium or tritium.
Some say this is a positive way to go because calculations show that a spacecraft propelled with nuclear explosions can reach speeds faster than 9,000 miles per second. This is approximately a travel time of 130 years to the star, Alpha Centauri. However, this ties down into laws. If any detonation of a nuclear device occurs in outer space,
it would violate the Partial Nuclear Test Ban Treaty. Even so, there are still safety concerns regarding a nuclear-based spacecraft traveling into space instead of using conventional rockets.
4. Solar sails. Instead of propelling a spacecraft by burning fuel or creating a nuclear explosion, solar sails pull a vehicle by using the energy of charged particles ejected from the sun as part of the solar wind.
An advantage is that this method is similar to a sailboat, as a sailboat utilizes the wind energy. A solar sail will likely cruise for a limited period of time.
However, even compared to conventional rockets, these travel much slower. Also, they will only work for certain missions as they require energy ejected from the sun or another massive star to travel.
5. Antimatter rockets.
This possible form of technology for the future uses the products of either gamma rays or highly charged subatomic particles we know as pions. It helps to propel the spacecraft through space. It is said to be the most efficient fuel possible, as almost all of the mass of the spacecraft that travels at speeds almost as fast as of light.
However, this is considered fantasy to certain scientists, mostly because we haven't confirmed a reliable method to generate enough antimatter for a space journey. Estimates say that a journey to Mars would require about 10 grams of antimatter. Today, we have only been able to create a low quantity of atoms of antimatter, which also consumed a large amount of fuel.
So making an antimatter rocket would be tremendously expensive, and it cannot be our only way of sending crafts outside our atmosphere.
What are some other ways of traveling far distances?
Well, scientists have thought of some radical ways of producing energy for interstellar traveling. One of the ways would be to manufacture a spacecraft that extracts hydrogen as it travels through space for use in a nuclear fission reaction. We could also use wormholes.
Oh, wormholes. The idea is to get a chunk of spacetime with a desired celestial transportation mechanism in it and move it faster than the spacetime around it. So the spacetime around it would be expanding behind it and contracting in front of it, allowing the vehicle to leap great distances in a short amount of time. If we found some way to alter the properties of spacetime, somehow expand spacetime behind the craft, spacetime itself will push the craft forward.
Scientists believe that altering spacetime properties might be creating time travel paradoxes. So doing this may cause you and your spacecraft to enter a constant loop of repetition, maybe seeing yourself enter into the paradox constantly over and over again. But in order for you to do that, you can be in the paradox itself, which then goes into some complicated details that won't be touched on. Some people ask if the Earth will ever overpopulate.
Well, the Earth is actually not in immediate danger of overpopulation. This misconception has been around for centuries. Overpopulation alarmism is driven by various political and environment ideologies. In 1980, a brief boom in births globally led some activists to proclaim that if trends continued, calamity would ensue. The only problem with this exercise and extrapolation is that trends did not continue.
Birth rates have been steadily declining. U.S. Census Bureau data shows that global population growth in 1980 was almost 2%. The rate today is about 1% and steadily dropping. If every family in the world had a house, if every house were stacked end to end and front to back in one gigantic complex, the entire current world population could be housed in California alone.
And this calculation does not include the possibility of building upwards. If people were to live in 100-story high apartment buildings stacked end to end, front to back, and top to bottom, then the entire world population could be housed in San Diego alone.
The problem with overpopulation disaster scenarios made by alarmists is that they typically extrapolate the population growth but don't extrapolate the advance of technology. The improvement in agriculture efficiency, medicine, and residential construction has outpaced the growth in population.
As a result, the world's standard of living has on average improved despite the population growth. This effect will continue in the future. It's true that there are ever more mouths to feed and cars to fill with gasoline, but there are also ever better ways being developed to make food and extract gasoline. Even if thousands of years hence the Earth did begin to approach dangerous levels of population and technological progress stalled, the decline in quality of life would naturally lead to lower birth rates long before the situation ever became cataclysmic. In truth, the Earth is far from overpopulation.
Thanks for watching a short video about life on other planets.
We hope you enjoyed it, and these theories presented may cause you to acquire more information.
If you are curious about a certain topic in this video, you can check out our trifold setup in the classroom.
Or you could ask us.